In 1981, two new transit systems were opened in the cities of Memphis, Tennessee, and Las Vegas, Nevada. Systems which promise to begin a new era in public transportation. Designed and built by VSL Corporation, the Metro Shuttle 6000 is proving to be the most reliable and economical system ever developed for short-distance urban transit. Throughout the world, public transportation has become one of the most critical problems facing cities today. The automobile, once viewed as the optimal means of transportation, is now the single greatest obstacle to urban mobility. Downtown business districts have become increasingly congested, and parking has become one of the most frustrating and time-consuming problems of modern city life. The problems associated with traffic congestion are far from limited to metropolitan areas. Shopping malls traditionally suffer from lack of convenient access and nearby parking. Frustrated and harried customers will not provide businesses with a lively economic future. These problems also hold true for new residential communities, medical centers, and most notably, airports. For air travelers, transportation from peripheral parking areas to the boarding gate is often the most difficult part of the trip.
I parked my car in front of the terminal to drop off my bags. When I get back in 5 minutes, I got a $25 ticket on my windshield. Must be a half a mile walk from the garage to the planes. Try walking that with a full suitcase.
The solution to today's intra-city transportation dilemma will involve the integration of existing systems with the whole new generation of innovative transit technologies. Many of these new systems, such as the Bay Area Rapid Transit in San Francisco, concentrate on suburban to downtown commuter traffic. But the great majority of transportation problems concern lack of mobility within the city. Transportation from peripheral parking areas to the passenger's final destination is a very important and often overlooked aspect of an efficient transit plan. The Metro Shuttle 6000 arose from today's need for an effective, energy-wise approach to short-distance urban transit. The basis of the system is the century-old technology of rope propulsion, a field in which VSL has extensive experience. New York City's Roosevelt Island Tramway, built by VSL in 1978, is a successful example of how ropeways can solve urban transit problems. The system provides residents of a new island residential community with access to downtown Manhattan. Operating on the same principles as the tramways found at many ski resorts, the Roosevelt Island system has outperformed all other transportation alternatives while operating around the clock. The system is quiet, non-polluting, and extremely economical to operate and maintain. The success of Roosevelt Island led VSL to begin development of a new urban transit system. Headquartered in Los Gatos, California, VSL Corporation is a diversified firm engaged in transportation and construction projects requiring special know-how and innovative engineering and manufacturing capabilities. As a subsidiary of Losinger Limited, engineers and constructors of Bern, Switzerland, the company is a member of a major international construction group with offices in over 30 countries. In the United States and Canada, VSL has a network of offices in 18 major cities with a staff of over 50 licensed architects and civil, structural, and mechanical engineers. Services provided range from feasibility studies to the design and execution of a complete turnkey project. Development of the Metro Shuttle took several years. during which VSL analyzed the objectives of all self-propelled people movers and compared them with cable-driven systems. It was found that for short-distance applications, a cable-driven system requires less initial cost to build, less energy to operate, and is more reliable than any conventional system. By using a fixed-track guideway rather than a suspended cable, the system would gain increased user confidence and would also be able to negotiate horizontal curves. In 1979, VSL began work on the two initial Metro Shuttle projects. The scope of these projects included the design, manufacture, and construction of a complete transit system. The first Metro Shuttle installation took place in the fast-paced resort city of Las Vegas, Nevada. Always a challenge to contractors, Las Vegas is a place with tight schedules and high performance demands by owners and developers. VSL has consistently met those challenges with success. The company provided turnkey construction for a 112,000 square foot expansion for the Dunes Hotel and Country Club. And VSL financed, designed, and built the city's beautiful new Valley Bank Center. In June of 1980, the Circus Hotel contracted with VSL for the design and construction of a 1,500-foot-long people mover to connect the existing hotel with a new 800-room expansion. The agreement called for the system to be operational in a period of only 11 months. Construction at Circus began in July of 1980. This included installation of the elevated guideway and the stations for housing the drive machinery and rope tensioning equipment. VSL's experience as a major construction contractor kept the project moving smoothly on a fast-track schedule. While work at the site proceeded, VSL's Magnus division was fabricating and supplying all mechanical components. Magnus is a major manufacturer of high-pressure hydraulic and mechanical equipment, with offices throughout the United States and Europe. The vehicles, drive machinery, and electronic control system were built in Switzerland by VSL's highly qualified group of subcontractors. Each of these firms is an acknowledged leader in passenger ropeway technology. Within 3 months after the components arrived in Las Vegas, final assembly was completed. The entire system was then thoroughly tested. In May of 1981, the shuttle was fully operational and open for use by Circus guests, much to the satisfaction of hotel management. Mel Larson, Vice President of Marketing for Circus.
The people like it, we like it. It moves the people rapidly, conveniently, comfortably, and but most of all, reliably. So we're very pleased, and it's become an attraction here in Las Vegas. We have people who call about it, ask about it, drive down, take pictures, come and ride on it, because, again, it's a trendsetter. We've, in our entire operation, we've tried to do that, to be number one, not a follower, but a leader, and so we think we've done it again.
The second Metro Shuttle system was built for the city of Memphis, Tennessee, to connect Memphis Civic Center with Mud Island Park, a new recreational complex located on the Mississippi River. Roy Harover, architect.
When the city required that we design a park to be built on a 50-acre piece of an island in the Mississippi River, one of the requirements was to get people from the downtown area over to that island. And a bridge was really the best solution. So we designed a 1,700-foot pedestrian bridge, walking only, to enable people to walk to the park. But there were obviously going to be some people, the handicapped, the aged, and the infirm, who would have to be carried there on some form of a people mover. since we had the bridge structure already there, it seemed very reasonable to hang the transit trains underneath the bridge. We found very quickly that this was something that had never been done in the world.
For the Mud Island project, VSL designed a system consisting of 2 vehicles suspended from a fixed guideway, each with a capacity of 180 passengers. Each vehicle has 3 sectional cabins with flexible joints to accommodate turns. The capacity of the system is more than 3,000 passengers per hour, making it the highest capacity ropeway system in the world. Although the Las Vegas and Memphis systems appear quite different from one another, they actually reflect an identical technology. Every Metro shuttle system consists of 5 basic components: the guideway structure, propulsion system, vehicles, automatic controls, and the communication system. The guideway can be located above the vehicles for a suspended or Type H system, or beneath the vehicles for a supported or Type S system. The vehicles ride on rubber-tired drive carriages which are locked to the guideway beams for positive guidance. Metro shuttle vehicles cannot be derailed. The fixed-track guideway also allows the system to negotiate curves and slopes of any grade, and requires no heating or shelter because water, snow, and ice will not affect the cable-driven vehicles. The rope propulsion system provides motion to the vehicle via the steel traction cable connected permanently to the undercarriage. A variable speed DC motor is connected through a speed reducer to the main drive sheave, or bull wheel, which propels the cable by traction. Because the drive unit is located in the terminal and not on the vehicles are totally silent during operation and emit no air pollution whatsoever. The absence of an onboard drive also makes the vehicles much lighter than those of a self-propelled system and allows them to travel on a lighter, less costly guideway. A crossover at the center span of the Las Vegas system allows the vehicles to bypass, while the trains of the Mud Island system ride along parallel guideway beams for the entire distance. The Metro shuttle vehicles are built of lightweight structural aluminum. Single or multi-unit articulated cabins are custom designed to fit project needs and passenger volume. The vehicles are fully integrated with boarding terminals designed for efficient entry and exit through the cabin's extra-wide biparting doors. Spacious interiors, enhanced by large windows, provide comfort for both seated and standing riders. Onboard batteries provide power for the lights, air conditioning system, door activators, and the vehicle controls. The batteries are automatically charged at each terminal stop by special third rail contacts. The air conditioning system employs a unique water circulating method. At each terminal, the vehicles connect with special couplers which inject chilled or heated water into onboard reservoirs. This system eliminates the need for an onboard compressor, which would add excessive weight and require system shutdown for repairs. The Metro shuttle control system is completely automated. Operation and boarding are monitored from the central control room using video screens and a complete intra-system telephone network. VSL trains all of its clients in the operation of the Metro shuttle system and will also operate and maintain the system for the client under a separate long-term contract. Civic planners and private developers in Las Vegas and Memphis see the new shuttle systems as major attractions for their cities. They also feel that the Metro Shuttle holds great promise for future developments in transportation. VSL's first two Metro Shuttle systems have proven that innovative answers to the world's transportation needs do not have to gamble on untried technology. Modern automation applied to a century-tested principle has produced a transit system brand new and unrivaled in safety, economy, and reliability. In view of today's mounting transportation problems and concern for energy efficiency, the Metro Shuttle 6000 is definitely a move in the right direction.